Good morning, everyone, and welcome to this early Thursday morning lecture. Well, I guess not earlier than normal, but it's still early. Right. For those that are here live, I'm glad to see you guys are still awake, or that you guys are awake. So know you guys are writing a semester test tomorrow. So we're going to try and keep things simple. I'm not going to overwhelm you with content today. I'm literally just going to show you one thing today. Which reminds me, I should probably do that in PowerPoint. Then we're going to have to change the wording on a slide in order to show that to you. Right. So, up until now, we've done random access files. We have shown you, to just get to the slide that I want. We have shown you how to write to a file, and we've shown you how to read from a file. And we've shown you how to use a hash function in order to write to a specific location in the file. Now, if I'm referring to a specific location, and it's not displaying on your side, if I'm referring to a specific location, I'm referring to the fact that it's a location determined by the hash value that the hash function will calculate. And that is now the input value being given to you, which is a key element from your data set, and the hash function doing its magic. In this case, it's the prime number algorithm, prime number divisor algorithm, where it takes the data value, divides that by the prime number, which is determined by the size of your data set, which is the closest prime number to the data set size or equal to the data set size, but doesn't exceed the data set size. So don't be too worried about the actual prime number value itself. It is a open book test, and if we do give you an example, or if we do ask you to do a random access files, then we'll provide you a list of potential prime numbers that you can use depending on the data sets, because obviously we're not going to give you all the same test, so the sizes will vary based on which paper you're writing. Okay, so what I want to add to that, so now we've told you how to find the location that you want to write to, now to find the location you want to read from. So that hash function will be used when writing, and that hash function will also be used for reading. Why did you stop that now? Let's just go back to my slide. So that hash function will be used for writing, and that hash function will also be used for reading. But there's one difference, or there's one addition I want to show you today. So the addition that I want to add to today's content is the size of the file. So when we're using hash functions, we refer to the fact that we've got a certain number of values available. And in this scenario, we said there are 18 spots available, 18 blocks, which means our file consists of 18 blocks. Now, because we know the data size of our file, I see you watched Mr. Gottschall's tutorial. We'll discuss that in the chat this afternoon. I'm just going to show you this set length today. So lset is a string operation, which basically just sets not random, but sets a number of strings, or sets a specific character a number of times that is specified. We'll discuss it in a bit more detail this afternoon. But if you have some time, I'll show you the code for that as well. It's not something that's going to be useful to you. I personally would rather write out that string, because it's just, like I said, you're just setting a character a number of times. It's basically a function to type out 20 spaces or 20 A's or 20 B's or whatever character you want, instead of just typing it out specifically, which in some case allows you to have an accurate number of characters, but If it's something small, like we'll most likely give you, we won't ask you to do anything above a 15 character length size. You might as well just type it out. It's you're not going to get any marks just for that specific function because it's a built-in function. You guys know how we feel about built-in functions. Where possible, we want you to do the code and not have a system do the code for you. You'll realize that in honors as well. We don't want you to depend on the libraries given to you. You need to be able to code everything yourself. It's very nice you can use libraries. I know children in primary school that can use libraries. You guys need to know how to use functions themselves. Now, when it gets to files, yes, we do depend on some of the aspects of the libraries that are out there. But the concept itself here is what we're doing with the files and the purpose of the files, and not the files themselves. Well, the files themselves, but not how to write them specifically. Because we're not looking at the structure. It's only in random access files that we're looking at the structure. Right. So, coming back to my suggestion or my point is we know that the size of the file is going to be set beforehand because we know how many data blocks or record blocks we're looking at. So in this case, we're looking at 18 blocks, 18 data blocks, which means with our example, if we take the example we use, the student number, the surname, and the double, we've got a 42 byte data block. So your file size, let's just see, let's get an empty page here. This one will suffice. So if you're looking at your file size, you're looking at data block. You know that you are going to have, you'll see some text popping up in a second. Right. You know that you are going to have 18 times 42 blocks as the overall size of your folder. Because we know that, because we know the file is going to be, what would that be? Let's just quickly check. That is 18 times 42. So you're looking at 756 bytes. We can set the file size beforehand. We can tell it what we want the file size to be. Now, the reason for this is so that you can not pre-calculate, but predetermine the file size. So instead of having the file itself being written while we do our writes down here, we can already have the file up here ready. So we just simply access the data byte or the byte blocks inside the file instead of writing and generating the bytes as we go along. So how would that look? The only command you need to know for this is file stream, set length, and excuse my spelling here, I suspect I might be making a mistake, and then giving it the size of the length. Now, in this case, we know it's 18 by 42, but because of the dynamic nature in which you'll be writing data, you'll most likely use a record size, a variable indicating your record size, and a record number indicating how many records you have. Because there will be a set value for you. It's not going to be something you can essentially just type it out if it's given to you, but ideally, because we want to keep our programs as dynamic as possible, you can just write out the values themselves. Just want to look at this comment quickly. Right. So, you're seeing my screen. So, the benefit here is because we know the size of the file, we can create the file beforehand. Keep in mind, this is only if you know the size of the file. If you don't know the size of the file, then this line doesn't matter. And there's a reason I'm leaving it to now, because up until now, you don't even have to use it. You can do this program without doing this file. But there's one benefit to doing this. And I want to see, let's just see, students that attended the Tuesday tutorials. It looks like most of you. I see about 4 names that didn't attend the tutorials. What do you think is the benefit of setting the file beforehand? Does anyone have an idea? Let's say everyone can answer, because I'm assuming the people that watch the tutorials are the only ones that will actually try. Precision, to a certain extent, yes. Not exactly, but yes. Being able to reserve correct, accurate space, yes. There's one more thing that you can add to that. I want to see who's going to identify that. Come on, I know you guys are typing it right now. Knowing the number of blank records, yes, but there's a benefit to knowing the number of blank records that are there. Can't be changed? No, it can be changed. You can still exceed the file size. The moment you try and write something larger than what the set file size is, it will create more. Knowing how much space you have left, not specifically, because it's not something you really track in your program. It's just you have the empty blocks there already created, so that all of the spaces are used, not specifically. So consider this. When you are building a house, you will build it brick by brick. We'll take a small house. You build it brick by brick. Is it going to be faster for you to create the brick while you're building it, or create the bricks before you're building it? Before. So this is kind of simulating that. It's you creating the spaces beforehand, which means accessing those spaces will be a bit faster because these spaces already exist. When you write to a space that doesn't exist yet, it first has to write the bytes, or the empty bytes or the space bytes, to generate that specific location. Whereas if it's generated beforehand, the space is already there. You can just simply access it and put your information in. Now, in terms of the speed of this application itself, it's only faster the first time you write to the file, because that's when you create the entire file size and then use everything after that. Sorry, from the second time, because the first time you have to write all of those blocks. So there is a payoff at the end. If it's going to be an extremely large file, like I accidentally demonstrated last night, no, Tuesday night, it will take a while to create this file. But once it's been created, accessing the file is a lot faster. But then again, if you're going to look at files of that size, a random access file is probably not going to be your go-to file. You'll probably use either something like a CSV file, or you'll move over to a database, depending on what you want to do with that. It's not really something that is that useful. It's good to know it. It's good to know that you can set the file size beforehand, so you can make sure you've got a specific amount of space reserved. But in terms of the overall benefit of speed, having the accurate file size set already, all of those things are just kind of nice to have, because if you're using a file size like this or a file like this, you probably have that space available in any case. But the main reason to set the file size beforehand is already having them, pre-allocating them, making sure you don't run out of space. Now, one thing to keep in mind, and I'm pretty sure one of you are going to run into this situation. Visual Studios, unless they've changed it, and this I've tested this earlier in the year, I'm assuming it still works the same way, unless you change it in the settings, only allows you to use about 2 gigs of memory inside your program, inside the active program. The moment you exceed 2 gigs, the program will stop and say it ran out of memory. Now, there is a way to increase it, but obviously I'm not going to show you that because you shouldn't be exceeding you shouldn't even be reaching 1 gigs of memory usage with your active program. Because it most likely means you did something horribly wrong. You've got a memory leak somewhere in your program. Which is not impossible. I mean, if you set a while loop and never end it, then you can very quickly run into a memory leak or a run out of memory situation. Out of resources error message. So, set length. A beauty, a gem, and in all honesty, technically utterly useless. Because the moment you have to set the length to actually reserve the size or increase the speed, there's better data structures out there. It's one of the reasons why I left it for last as well. Because it's really not that useful. The program's going to work the same whether you have it or not. The sizes of the files that you're writing, it's going to be the same. But if you were ever curious in creating your own database, that's kind of how you would start it. Especially if you're going to reserve sizes. Now, that being said, are there any questions from your side? I literally just want to do something simple with you guys today. I know you're writing a semester test tomorrow. Most of you are starting to get tired of random access files because we've covered it for about 4 lectures now. So I just want to do something small to tie it off. And this essentially will be the last lecture on random access files. And next week, Monday, we'll start with collision handling in hash functions. Please re-explain the use of hash. All right. I kind of expected that as well. So I've got the right set open for that. Now, the idea behind the hash file, and we'll discuss again on Monday when we have I'm going to set up a slide that will kind of show it a bit better to you. A hash allows you to convert a value using a mathematical calculation into a set size output. Now, in our case, our set size output represents our integer, which is a 4-byte output. So the value that we expect is a 4-byte output, and in our case, the hash function is limited to output a value between 0 and 17. The hash function itself is supposed to output a unique value. I'm saying unique, but it's not always unique depending on the nature of the algorithm. So in the case that we have, our data set is only as large, or our output is only as large as the largest prime number closest to our data set, or equal to our data set, but doesn't exceed our data set. It allows us to find a unique location based on the key value being given to the function. This value of any size gets converted and then gets hashed into a set size. Now, when I say a set size, I'm referring to the fact that the output will be of a fixed data nature. In this case, it's fixed to a 4-byte integer, limited to 0 to 17. Now, hash functions in a more advanced nature, it's used to verify file information. So you would hash an entire file, an entire string set, an entire paragraph, an entire page into a value. And then that value was stored. Or not stored always, but used to verify whether this file has been changed or not. Because if you change one character, regardless of where you change it, if you change one character, the output will be completely different. The reason for that is so that you can check when files have been corrupted and files have been changed or modified. So you'll most likely see a lot of the times when you're downloading a installer, they'll give you an MD5 or a SHA-1 hash value and tell you this is the hash value for the function. So if you take the file, the installer, and hash it, you should get the same hash value, because that will then indicate that the installer is complete, not corrupted, and that it has not been changed or modified in any way. That's just one way of using it. The other way of using it, as you're using it, you can have a hash map. A hash map refers to the fact that the hash function, the hash value, the value you get from the function, is a location. This location identifies where you can find additional information. And that is how we're using this hash. We want to make sure that our output fits within the data size, so that we don't have to create files that are stupidly enormous, as with the example I gave you up here. If you use the ID number of the student, or the student number essentially, and multiply that by the data block, you have so many wasted space. And we can't even reach this specific number because Access won't allow you. It exceeds the actual allowed file size, or the actual allowed active memory used in the Visual Studios. Well, for me, because I haven't modified it, so it's still set to the default 2 gigs. All right. We'll discuss it a bit more again on Monday. Like I said, I'm going to have a slide set for you, because we need to discuss hashing again, because we're going to discuss collisions, how to handle collisions. And then I'll actually have a nice little, I say animation, it's probably just going to be duplicated slide sets with a small change in between. But there's going to be an additional guided slide that shows you where functions will go, where values will go, and how to deal with them once there is a collision. But the idea is that you get a return that should be unique to the data set being given. Or in I say unique, but it has a specific output. We're going to say a specific output because the nature we're using it, it's not going to be unique. Something like the SHA-1 hash is intended to be unique, but has been proven not to be unique. If I remember correctly, they found a collision with the SHA-1 hashing last year. And that was after a few billion iterations that Google went through. I think it was Google. Right. So, are there any other questions? I'm not seeing any other questions. All right. That being the case, that will be it for today. Like I said, today we're going to keep it short and simple. It's literally just this concept, the set length that I wanted to show you. My mind hasn't really woken up yet, so I can't tell you if I spelled correctly here or not. I'm sorry about that. Set length, it looks correct. So, semester test, past papers. More past papers. You have like 3 of them already. Understand that more past papers will help you to prepare, but you already have 3 of them. 2 of your practicals were past papers. In fact, I think 3 of your practicals were past papers. So other than what has already been released, I don't think we're going to release more. I think 3. Prac 9, no, okay, 2. Well, let's say 2.5, 1.5, because Prac 9 was slightly modified not to include files. Oh, it was 3, so Practical 8 was also a past paper. Slightly modified not to include files, though. Right. So the questions are not on topic, so I'm going to stop the recording here. For those that are watching the recording, it's short and simple, because those watching the live stream, you're writing a semester test tomorrow. I'm honestly surprised that we have so many here this morning because you're writing a semester test tomorrow. But then again, you are probably still asleep. You asked a question where, oh, for line 3, we only hash for ID and other information for student like surname and average. We leave out. So the ID is what's going to determine your location, and that's your key value. It's the key. It's what you're using to store the information. Once you have the information, so this just identifies the starting block, the starting byte of where you're going to write information. Once you have the starting block, then you will start writing. That hasn't changed. The hash function itself is just helping us find that block. Instead of finding block 217 million something, we're now finding blocks 0 to 18 after the hash has been completed. Can we get the version including files if possible? We'll discuss in the chat this afternoon. We'll discuss in the chat this afternoon. So maybe just stop by so that you can find out. Or watch the recording. Or check Eve, because obviously if you win the discussion, we'll just post it on Eve. Right. So if there are no other questions for the live stream, then I'm going to stop the recording right here. And then I'll still stick around for another 10 minutes or so that you can ask questions. Otherwise, I hope you guys are studying for your semester test. I know some of you are writing tomorrow. I know some of you wrote earlier this week. You're probably still recovering from that. And you're writing next week as well. So the scope for next week's test is everything we've covered so far, as indicated in the learning guide. The date and the time is set there as well. So please make sure you know what time you're writing, when you're writing. It's next week Friday. It's during the practical brackets. So there's no reason for you not to know. Everything we've done up until now, we will discuss during the tutorial, if that includes more or less. But it's everything up until now, so that includes random access files. But we'll discuss it during the TUT. Let's just say it's beneficial for you to attend the TUTs, all of them, until you write your test, and all the lectures. Whether it's recorded or on Eve, recorded or live, doesn't really matter. It will be discussed during one of the recorded sessions. And obviously the information being discussed in class, being that it pertains to your semester test, will be posted on Eve as well. Right. And with that, I will leave you guys for today. Well, for now, you still have your TUT this afternoon. And wish you guys good luck for your test tomorrow, those that are writing. And please make sure you do study for them. This is the practice test. It's easy, only if you study, only if you've been doing your own practicals.